Hello. Today we'll be dealing with acceleration. And acceleration has a simple equation, but it could get complicated. Let's see how it looks. So, acceleration of an object is simply acceleration equals change in speed. This means change in speed. This triangle means change, and of course change in speed divided by time. So that's acceleration. However, what if I want to find change in speed and not acceleration? Okay, let's move time up. I'm going to move time up. I will move the time, okay, my time up next to acceleration to leave change in speed alone. So now I have acceleration times time, whether it is in seconds or hours or minutes even, equals change in speed. Okay, now you're saying, but this question that I'm given says that I need to find the time. And they do give me acceleration, and they do give me change in speed. Okay, simple. Now I will bring the acceleration down. I will take this acceleration and move it down. Down where? Underneath speed. So I will leave time alone. Time stays where it is. I am not moving that because I'm solving for time, and that equals the change in speed, whatever speed that was, okay, over my acceleration. Now, what are those units? Time is either seconds, it could be minutes, it could be hours, anything dealing with time. Speed itself, it could be meters per second, it could be miles per hour. You just have to be careful as to what's given to you. And acceleration, okay, it's a tricky one. It is usually something like meters, let's say meters per second square. Okay, it's something like that because you have to look at the distance and the time is squared. Okay, this is a simple format of acceleration. Now let's look at a more complicated format of acceleration. Okay, so let me rewrite the equation of acceleration. Okay, and I'll say acceleration equals change in speed. But the change in speed is simply the change in the speed. Like I said, it's the final velocity, whatever velocity you ended up with, velocity minus initial velocity, whatever velocity you started with, divided by your time. Okay, you're saying, how does that help me? Okay, if you want to solve for final velocity, leave it alone. So move everything around final velocity away, and I have acceleration times time. Okay, and you want to leave final velocity alone, so please remove away from there your initial velocity plus initial, let's abbreviate this, initial velocity. That gives you your final velocity. Now you're saying, what if I want to solve for initial velocity? Good, so leave that alone, and I go initial velocity, initial velocity, leave it alone, move everything away. On the right side I have final velocity, so final velocity, final v, minus all of this, minus parenthesis acceleration times time. Good. As you could see, the equations could be manipulated in the format that you want to work it on. Whether you're looking for it is acceleration, or change in speed, or time itself, or in this case, on the expanded version of it, okay, I have acceleration, final velocity, initial velocity divided by time, and whatever unit, whatever variable you want to solve for, you have to make sure that the other variables are moved away. In the case of time, of course, it is at the bottom. I bring it to the top next to acceleration, and that is multiplied. And in the case of final velocity or initial velocity, be careful moving those because it's a plus and a minus, and sometimes it could get a bit difficult in the way you view the question. However, having simple algebraic knowledge should help you manipulate all these variables and find the one that you're searching for. I hope this helps you out.